All right, here we go. We are now going to move on to orbital motion part 2, where we look at how most planets and celestial bodies, when I say celestial bodies, I'm talking about planets, moons, anything that might orbit around another thing, that's a celestial body. All right. You'll click on your notes here. I'm going to click over here because mine are already like pre-recorded. Not pre-recorded. This is special. Anyway, so when we talk about how something moves in space, you might have noticed from the activity we did yesterday where we were manipulating the mass and therefore the gravity of different objects, that there are times where it looks more like a circle, the orbit does, and there's times where it might look more like an egg. When something is elliptical, that's just a fancy word for oval. Okay, so an ellipse, an elliptical, same word, just different, I guess, pretenses or, different forms. But when we describe how oval shaped it is, we're talking about eccentricity. Boop, 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 boop. All right, and this measures how far an orbit is from a perfect circle. So a perfect circle is 0, and 1 is the opposite of that, and that would be like a line. So Earth is at 0.017, so it's very close to a circle. Let's double click here. And what you're doing is you're going to be moving these circles that are turning into ellipses onto this like thing right here to show how as you get closer to 1, as an ellipse gets closer to 1, it's going to be closer and closer to a line. All right, save. Okay, so if I look at the notes, here we are. And if you take note here of, let's move this up, of this guy right here, it has all the planets and their eccentricity. And you should be able to identify, hey, which planet has the most circular orbit? Which when you look here, which is the closest to 0? Well, Venus is very close to a circle for its orbit. But again, it's not a perfect circle. It's not at 0 exactly. So it's close to a circle, but it's not exactly. And then you look at, all right, which one is closest to a line? Well, Halley's Comet, if I look here, let me show you. Halley's Comet orbit, boom. Images, boop. Every 75 years, this guy comes around. So compared to all the, wow, what just happened? All right, I like this one. So those are all relatively circular. They're not perfect circles, but they're close. Compared to this, it's very eccentric. So it's very, very squished. Okay. Now, when it comes to the parts of an ellipse, you have foci. So let's highlight that. A circle has one focus, and an ellipse has two foci. So if I was going to draw this, let me show you. You don't have to do this. I'm just trying to show you an ellipse. I wish this was like paint and I could put a dot. So in the very center of the circle, you would have one of those. And then for an ellipse, you're going to have 2. So 2 focal points. Grab you. Can I grab you? Ooh. Oh no, that's not what I wanted to grab. Hold on. let's move you to right there, and then we'll just pop you over top. So an ellipse has 2 focal points, whereas a circle just has 1 that it travels around. All right, so save and close. Again, you don't have to do that because you just saw how frustrating that was for me. But you do need to know that an ellipse has 2 foci, 2 points that it goes around. When we're looking at the shape, you have the major axis, which is right here, and that is the longest part of the ellipse, and it crosses both foci. So it goes through one, goes to the other one. And you'll notice that for a planet, the sun or that planet's star is going to be one of the focuses, one of the 2 foci. Okay? All right, so where's my notes? There we go. So the longest part of the ellipse is the major axis. Now, there's also 2 points called perihelion and aphelion. Perihelion is the point of the orbit when the planet is closest to the sun. For us, that actually happens in winter. We're closer to the sun during the winter, which you might be like, oh my gosh, that's so crazy. I don't get it. Remember, we're very close to a circle. So us being a little bit closer to the sun isn't going to affect how hot we are. What's actually making the seasons, again, is our tilt. During the winter, even though we're closer to the sun, we're not tilted towards the sun. We're not getting direct sunlight. Aphelion, which happens during the summer, I always remember the song I Got a Feeling, and I changed it to I Got a Feeling. It reminds me of summer. So that's a point of the orbit when a planet is farthest from the sun. And we are further from the sun during the summer, but we are leaning towards it, leaning towards the sun, so we're getting that direct sunlight. Okay. On here, let's put these on here. So this little dotted line is showing us our major axis. So we'll go ahead and pop that up there. The sun is one of the 2 foci. So we'll put that guy right on there. Bam. This is pointing to our orbit. And then aphelion, remember, is the summer when we are furthest from the sun, opposite of what you would think. So there's the sun, there's the planet, and then perihelion, I always think of polar bear starts with P and it's cold and winter's cold. I don't know. Do what you got to do to remember. Perihelion means we are closest to the sun. But again, we're tilted away. The northern hemisphere is tilted away. Save and close. And that is the notes you need to know about the shape of planets' orbits and some of the actual terminology. All right. Have a great day.